If you look at problem 151, you'll see that the answer is actually given within the problem itself. This is a question where you need to choose the option related to converting pressure into an electrical signal. The correct answer is choice B. You can see that this sentence refers to the piezoelectric effect. Next, let's look at problem number 152 below. If you look at the problem, it asks about something related to electrical focusing. Among them, the transmit mode, which in Korean can be called transmission focusing, is being referred to here. This is a question where you need to select the option related to this. The correct answer would be choice C. The most important point is that transmission focusing applies a time delay when the signal leaves the crystal. On the other hand, in the case of reception focusing, the time delay method is applied after receiving the returning signal, so that's the difference you should note. Since transmission applies a delay right when the signal first leaves the crystal, you can see that the sentence here is related to that. On the other hand, in this case, since the delay is applied after the signal has already been received, you should consider this expression as a sentence related to reception focusing. Now let's move on and look at question number 153. Since this is a basic question, let's go ahead and find the correct answer right away. The things related to this expression are those that play a role in reducing the grating lobe, which is answer B. As for the side lobe, remember that the difference is that it is related to apodization, which I explained earlier. Sometimes questions like these are alternated to confuse you. So, to summarize, side lobe is related to apodization, and something like subdicing here is associated with grating lobe. Now let's look at question number 154 below. This question can also be easily answered by identifying the keyword. Among the components of the transducer, the question is asking which part, called the ringing, is the area that controls resonance. The correct answer is A. The backing material, also known as the damping layer or absorption layer, is the part that controls resonance. You can see through this question that these two keywords are directly related. Now let's look at question number 155 below. Since I've explained this type of question before, let's go straight to finding the correct answer. Yes, this question is asking about the main advantage of using an array-type transducer. The correct answer here would be option 2. The most representative feature of the array type is that it allows for electronic focusing and steering. I can also explain that questions simply asking for the biggest advantage like this tend to appear more frequently. Now let's move on and look at question number 156. So we've already solved many questions related to the Q factor earlier. This question asks you to find the option that is not related to low Q. In the case of low Q, it is characterized by a broad configuration and a short SPL output. Therefore, the term long pulse length does not fit with low Q, so I can explain that this is the answer that doesn't match. Let's look right below at question number 157. This question asks you to select the item that corresponds to internal focusing among the topics related to focusing. Focusing can be largely divided into two types, internal and external focusing. This method induces focus by directly shaping the crystal. External focusing, on the other hand, induces focus using external elements outside the crystal. That's the main difference. A representative method of internal focusing is arranging the crystal in a curved manner, so you can select option C as the correct answer. Cases like options A and B are the most representative examples of external focusing. It also mentions techniques like options D and E, but these are not common patterns. So just remember that options A and B are the main examples of external focusing. Now, let's move on and look at question number 158. The key point of this question is actually at the end. The key point here is that the transmit pulse has been increased. For example, if the pulse wave was originally at this level, increasing it means that a greater amount of pulses is being emitted. When this happens, the pulse length becomes longer, and as the length increases, the SPL also rises accordingly. These factors can be considered items that may decrease axial resolution, You should review how these two aspects are related through this question. Next, let's move on and look at question number 159. This question is a bit long, but ultimately what it's asking is right here, spatial resolution, which we call Gongan Bonhenung in Korean. It's asking what spatial resolution is composed of. The correct answer is that it is composed of axial and lateral resolution. Even if you don't bother to interpret the long sentence at the beginning, as long as you understand the context and grasp the main point of the question, you can immediately find the correct answer. This is the kind of pattern I can explain here. Next, let's move on and look at question number 160. In the case of this question, it's a pattern where you can organize the content through problem solving. There's a term called radio frequency shield. Looking at its position, it says that it surrounds the crystal and the backing material. If you draw a diagram, the crystal is located at the front and behind it is the absorbing layer. The radio frequency shield mentioned here can be thought of as a protective layer that surrounds these two components. The question is asking about the purpose of using this shield. If we look for the correct answer right away, we can choose option D. So we can say that this shield is used to reduce incoming electromagnetic interference. Instead of simply examining the underlying mechanism in more detail, it is significantly more efficient and much faster to understand through this specific question that the primary purpose of using such a protective shield is to effectively minimize and mitigate external electromagnetic interference.